Thank you, everybody, for joining. This is part of the Colorado ENP study session series. I forget which number this is. Is this number 5, Jennifer? Yes, it is. It's number 5. The topic for tonight is classes of service. That title is a little misleading. I came up with it to talk about the different types of ways that 911 calls can come into the system, can come into a 911 network and be delivered to a public safety answering point. It is not limited just to we're not really going to be talking about the list of codes that can come in on an alley screen for class of service, but we're really talking about the different ways that 911 calls can be delivered into a 911 network. As I go through this, if you have questions, feel free to raise your hand or just unmute yourself and ask the question. This goes a lot better if we have questions to address during this session. Otherwise, you can ask questions at the end. And I hope you find this useful. This is being recorded and will be posted on the Colorado 911 Resource Center website. This study session series is being brought to you by the Colorado 911 Resource Center, the 911 Training Standards Institute, and the 911 program of the Colorado Public Utilities Commission. What we will cover today, we're going to talk about voice over IP or Internet Protocol, otherwise known as VoIP services. We're going to talk about commercial mobile radio service, or CMRS. That is the technical term for wireless or cellular 911. Or wireless and cellular services in general. We're going to talk about multi-line telephone systems, or MLTS. We're going to talk about how those interconnect with the 911 network. We're going to talk about text to 911, which is technically not a class of service because it doesn't come in with an alley screen, at least in most cases right now. And we're going to be talking about real-time text, which is sort of the next evolution of text to 911. So these are a collection of different ways that people can call 911 or contact 911 that didn't really fit into any other section of the sessions for this ENP study series. So that's what we're going to be talking about today. So we're going to start with VoIP, or Voice over Internet Protocol. And when you see this abbreviated, if you're not familiar with this abbreviation or this acronym, it usually has the O as a lowercase. So it's uppercase V, lowercase o, IP. And it refers to the delivery of telephone-like, usually two-way voice calling over an IP network. The voices of the participants in the call are digitized, broken up into packets, and transmitted over an IP connection, either the public internet or private network. Now, if you were in my other class a couple of weeks ago where I talked about different transmission methods, the breaking up of data into packets and distributed that way is basically how the internet works, and that is how voice is delivered over a VoIP connection. So it's connected between two endpoints of the call. Upon arriving at the other endpoint, the packets are reassembled into a data stream and turned into audio for the user. Technically, we're on a VoIP call right now. We're on a VoIP call that also includes video. But what you're hearing, my voice right now, is actually being broken up into little packets of ones and zeros transmitted across the internet. And then on the other side, on your computer, it is being reassembled into an audio stream that you're hearing out of your headphones or out of the speaker on your computer. So this is a VoIP call. A provider that offers VoIP service is called a VoIP service provider. You can see that's abbreviated sometimes as VSP. So if you see that on the test, that's what it's referring to as a VoIP service provider. We'll talk a little bit about interconnected versus non-interconnected VoIP. This was really important in the early days of VoIP regulation when the FCC, the Federal Communications Commission, was trying to decide whether VoIP services had to support 911 service for their users. Some private VoIP services do not connect to the public switch telephone network. Again, remember that acronym, it's PSTN. I almost guarantee you will see that at least once on your test. PSTN is Public Switch Telephone Network, and it basically just means the whole world of telecommunications that everybody can use to call anybody else. But some private VoIP services aren't connected to that network, meaning that they cannot be used to call people with phone numbers that are not part of the VoIP service. And people using other services can't call them. The service can only be used to call other users of the same service, and this is referred to as a non-interconnected VoIP. And services such as these are generally exempted from regulation, and you cannot use them to call 911. The famous example of this is Skype, which is, if everybody, probably everybody at some point has used Skype, or maybe at least is familiar with Skype. That was Microsoft's video/voice service that they used. It was really popular in the early days of the pandemic, for instance, before Zoom kind of stepped up and people started using that more. And the thing about Skype is that originally you could use it to call other Skype users, but you could not call anybody else with it. A Skype user could call another Skype user, and that was it. That was all you could do with it. And so the FCC referred to that as the Skype exception, meaning that they were not going to try to require that service to support 911 for their users, because the service was not designed to connect with the rest of the public switch telephone network. Any VoIP service that can be used to call any other phone number is referred to as an interconnected VoIP service, because it is interconnected with the public switch telephone network. And the FCC does require all interconnected VoIP service to support 911 dialing. Examples of those are Vonage, Comcast VoIP phones. If you have a Comcast phone in your house, that is a VoIP phone that is operating over the internet that you're getting from Comcast. And you can call any other phone number that's out there in the world using that phone. It doesn't have to be another Comcast customer, so they are required to support 911 as well. Magic Jack is another one. There's a lot of different VoIP services out there, and if you are able to use them to call other numbers that are not part of that same service, then they are required to also support 911 calling. VPCs are and dynamic alley for VoIP. We'll talk a little bit about those. So VoIP calls to 911 are relayed first to what's called a VoIP position center. So if a user using a VoIP service calls 911, that call first goes to a VoIP position center, or VPC, and the VPC determines which 911 network should handle the call based on the registered address of the user. It's really important to note that this may or may not be accurate, because unlike other types of services, the VoIP provider has no idea where you are unless you tell them. So one of the things they require you to do generally is to give them an address, a 911 address. But if you pick that phone up and take it anywhere in the country or anywhere in the world, really, and plug it into an IP connection, it'll still work. And the VoIP service will have no idea that you moved that phone. So that's a very important difference in how VoIP services work with 911 compared to other types of telephone services. But based on the registered 911 address that the user gives to the company, it will determine which 911 network should receive the call, and it will transmit the call to that 911 system service provider. In Colorado's case, that's CenturyLink. They're the only 911 system service provider in the state. And it will provide routing information. The 911 system service provider will then route the call to the appropriate public safety answering point. In an E911 network, the alley record is created for the call dynamically, meaning that it does not exist until the 911 call is made. The VoIP positioning center will transmit the alley data to the 911 system service provider, which will then build the alley record for the call. So to kind of step through this, the caller calls 911 on a VoIP phone. It goes to a VPC, which determines which 911 system service provider to send it to. The call is transmitted to the 911 system service provider along with routing information. The 911 system service provider sends the call to the appropriate PSAP, hopefully. The PSAP the PSAP equipment will automatically do an alley bid. The first alley bid is automatic. And by the time the alley bid, the request for the alley goes to the alley database, a temporary alley record has been built within that database that will have the 911 address in it. So that's sort of the call flow for a VoIP call. VoIP calls are very different from landline service as it presents in the PSAP, so it's important to know these things. As I said, the address that displays on the alley screen is one that the user provided to the VoIP provider and may not be accurate, particularly if they moved to the phone or they didn't update their address. A lot of these VoIP providers will try to verify the address using a national postal database, but sometimes they may not get it right. So if the caller puts in an inaccurate address to begin with, the VoIP provider may not know that it's not accurate. So the address that shows up on your screen, it's especially important. It's always important, of course, to verify the address on the alley screen, but it's especially important if you see that it is a VoIP call based on the class of service. One problem with a VoIP connection could be a problem with, if you have a problem with a VoIP connection, it could be a problem with the VoIP provider, but it also might be a problem with the internet service that's being used to transmit the call. Sometimes they're the same company, but often they're not. So an example of when they're the same company, I mentioned Comcast provides cable TV, but also they provide internet service, and they also sell VoIP phones. So if you have a Comcast internet service and a Comcast VoIP phone, and the quality of that service or the call keeps dropping, if the quality's bad or the call keeps dropping, it could be a problem with the Comcast VoIP service, or it could be a problem with the IP, the internet connection that is being used to transmit that VoIP connection. If you have Vonage, however, that is a VoIP service that can run over any other type of internet service you have. So you might have Comcast, or you might have CenturyLink internet, you might have Hughes satellite internet. If you are running Vonage phone on any type of internet connection and there's a problem with that connection, it could be Vonage that's the problem, or it could be the internet provider that's the problem. And it's really hard to tell what that is. A low quality VoIP connection can result in compression, which removes background noise from a call to reduce bandwidth. This used to be a problem generally because bandwidth that was available to the public just wasn't that high to begin with. So all VoIP connections, all VoIP calls had this problem where you could hear the caller talking, but if there was any noise in the background, that would get filtered out because there just wasn't a good enough internet connection to give you all of that detail. And as a 911 call taker, you know that background noise is very important. It helps you understand what's happening in that call. You can hear if there's a fight going on. You can hear if there's engines revving. All of that can be very important information that you may lose if the IP connection or if the internet connection for that VoIP call is not very good. Sometimes you can tell if the call is being compressed, if the caller's voice sounds kind of digitized or robotic, or like they're singing into one of those what's that called? Auto tuners. If it sounds like they're talking into an auto tuner, that can sometimes mean that the internet connection is slow, and so the bandwidth is lower, and it's compressing the data into a smaller and smaller number of packets, which reduces the quality of the call. And if you hear that, you know that there may be background noise that you are not hearing on that call, because that's the first thing that gets lost. And it's also important to note that VoIP calls make up only a small fraction of the 911 calls in Colorado. I didn't look up the exact percentage. Jennifer may have those, but we know from the data that we get from CenturyLink about the class of service for the calls that happen in Colorado, that VoIP calls make up a single-digit percentage of the calls in the state, compared to, especially to wireless, which is our largest number of calls in the state. That was VoIP. Does anybody have any questions? That was the super high level degree of VoIP, but I wanted to make sure that I was covering the stuff that was in the study guide. Jennifer?
I don't have any questions, but just to give an example, so far from July to November of this year, our VoIP calls are 6%.
Yep, 6%. I thought it was like 6 or 7%, something like that.
And then for the July to June of 2023 to 2024, our total VoIP calls were, hold on just a second. Yeah, 6.13%.
There you go. So they're not very common, but they can be a challenge when you do receive them. So it's important to be able to recognize those. And what it shows on your alley screen, it will have a class of service for VoIP. What it shows specifically may depend on how you have that set up in your phone system. But if it shows a VoIP or VoIP related class of service, you should be aware of these potential issues. Part 2, we're going to talk about CMRS, wireless or cellular. So the technical term for wireless calls is Commercial Mobile Radio Services, or CMRS. You see this a lot in FCC documents. Whenever they're talking about wireless calls, they usually say CMRS instead of wireless, or they may use the terms interchangeably. We also talk about cellular telephone services. Technically, cellular is a brand name. It's kind of like Kleenex. It's one of those things that was a brand name, but then became sort of a generic through use over time. So you will hear people say cellular calls or cell phones, but those are technically a brand name. So they're not frequently used in official or technical documents. A company that provides CMRS is called a wireless service provider, or WSP. But you will also see the term cellular provider or CMRS provider. So if you see any of those terms, they all mean the same thing. So it's not enough that we have a lot of acronyms, but some of the acronyms are synonyms. They're synonymic acronyms. Say that 10 times real fast. The customer's handset connects to a cell site, which is often but not always located on a tower. So towers are typically have 3 cell sectors, which are pointed in different directions to connect to the handsets in a wedge-shaped area. And I've got a diagram here in just one slide to kind of show you what this looks like. But handsets are constantly checking for cell signals in the area and will switch from one cell site to another to maintain the best signal. This can even happen in the middle of a call, something referred to as a handoff. So when you receive a 911 call from a wireless device, which 90% of all the 911 calls in Colorado are coming from wireless devices. So this is a very common way to receive a 911 call. When you receive a 911 call from a wireless device, the cell tower that's being used to deliver that call to you may not be the same cell tower at the end of the call that it was at the beginning of the call. So that's something that does happen, especially if the caller is moving. But it could even happen if they're staying in one place, because the signal that's available to that caller, especially if they're in overlapping cell sectors, may be stronger from one cell tower to another based on atmospheric conditions and lots of other things that can affect those cell signals. So here's a diagram. It's not actually a diagram. This is called a propagation map showing cell sector coverage. So if you look, and I'm going to use my mouse here to kind of show, we've got these 3 green lines here. This line here where the number 3 is, that is one cell sector, and this propagation map is showing where the cell sector has coverage. And then there's sector 1 and sector 2. So if you're in sector 1, that is the cell sector. There's going to be a directional antenna on this tower pointed in this direction where 1 is, showing this sort of wedge-shaped area, and that is the cell sector that you're going to be connecting to. Typically, there are 3 per cell tower, but there can be other numbers of them. 3 is just always the way they've traditionally done it, but they can do different numbers of them based on the terrain and other factors. So there's some specific terminology to be used that's used in commercial mobile radio service that is pointed out in your study guide. And a lot of it has to do with the different types of technology that's been used to provide wireless service over the years. And I put these in order. So the oldest type of technology that was used to provide wireless telecommunication service was called Code Division Multiple Access, or CDMA. I can't tell you whether or not that's going to be on your test. If it is, please note that you have gotten a very rare question because it's going back to the very beginning of wireless telecommunications service. This is basically the term 1G didn't exist yet at that time, but this is 1G as opposed to where we are now with 5G. Global System for Mobile, or GSM communications, was the next evolution of wireless telecommunications. Today, that's called 2G. At the time, they didn't have a name. They didn't have the G sort of way of classifying the evolution of wireless telecommunications. So it was just called GSM. And then they went to Universal Mobile Telecommunications Systems, or UMTS. And today we call that 3G. And then long-term evolution, or LTE, which I think most people have heard of because they started using that term quite a bit when they went from the earlier versions of wireless telecommunications to the newer version, LTE. Another term that is used to describe our current system that is not used in the public very much is IP multimedia subsystems, or IMS. And those two things together provide a higher bandwidth connection to the phone, which improves voice quality, but also improves internet capability on handsets for smartphones. And IMS is the subsystem or the system that they use to deliver multimedia to your phone, meaning pictures, video, things like that, especially if it's going not through an internet connection, but to your text messaging. And that's what these two things together are, what today are referred to as 4G. And now we have 5G, which is kind of, you would think, okay, so what's the new technology for that? It's the same technology. The difference with 5G, though, is that they add in high frequency small cells for higher bandwidth in urban areas. So it's still LTE and IMS being used to provide 5G, but what they call 5G is actually a higher frequency, smaller cell range that they put in urban areas that gives you a much higher bandwidth for those high traffic areas. Each of these advancements is mostly about bandwidth, not about voice service. Back in the very old days, if you're old like me and you had one of the first cell phones that were out there, the voice quality was pretty terrible, but that was mainly because there weren't very many cell towers. Every one of these technology advancements was more about getting data to the phone than it was about improving the voice quality. There are other ways that cell service is delivered to the public to help fill in the gaps in coverage. Wireless service providers sometimes deploy things that are called small cells. These are basically cell towers, but they cover a very small area. They can be anywhere from as small as 10 meters, which is 32 feet, up to 1.2 miles. Now, 1.2 miles sounds like a lot, but the typical cell tower can have ranges of up to 45 miles. So these are actually still very small cell service areas. And they're typically used to fill in small areas where there's just a gap in the coverage from the traditional cell towers. A femtocell is a type of small cell which is only big enough to cover a home or a business and is sold to the customer as a cell booster. You'll see these a lot of times, or not as much anymore, but you used to see these sold quite a bit in rural areas where basically the femtocell would connect to the internet, and the femtocell would serve as a small cell tower that would only cover a home or a business in an area where there just wasn't any other coverage. So if somebody wanted to have cell coverage in their home, they could buy one of these things, hook it into their home internet, and that would give them coverage in their house. 5G towers are smaller than typical cell towers. So we talked about the difference with 5G. They tend not to be nearly as tall because they're not intended to cover as large of an area. Because they are high frequency, and higher radio frequencies don't travel as far as lower radio frequencies, but they carry more data. So that's why they're used as part of 5G to improve the bandwidth in high density areas like downtown Denver or Colorado Springs or Fort Collins. Those are the types of places where you're going to see a lot of 5G towers. And they're typically, I want to say they're typically like 20 to 30 feet tall, so they're not nearly as tall as a regular tower. And they don't have multiple cell sectors on them. They usually just have one 360 cell sector on them. So there's some specific things that you should be aware of regarding how 911 calls are received from CMRS devices or wireless devices when they come into a public safety answering point. The address displayed on the alley for a wireless 911 call is the address of the cell tower and not the address of the caller. If available, every place in Colorado, every PSAP in Colorado is a phase 2 wireless PSAP, meaning that it can get location coordinates for wireless calls. So if available, the XY coordinate of the caller will also be provided, usually on the second page of the alley display, depending on how your phone system displays alley. But the address on the first page is always the address of the cell tower, not of the caller. So that's very important to keep in mind. Until recently, wireless calls were routed based on cell tower address, not the caller's location. But this is changing due to FCC regulations. The wireless carriers are currently in the process of transitioning to what is called location-based routing, or LBR. But until recently, calls were routed based on the cell tower address. And because, like I mentioned earlier, those cell tower ranges can go all the way up to 45 miles. That means that one cell tower sector can cover more than one PSAP service area. So it was very frequent and very common for you to get at the PSAP a wireless call that really should have gone to a different PSAP, and you'd have to transfer it. And that's why the FCC has been putting pressure on these companies to start doing location-based routing. With the newer technologies in wireless networks, almost all voice communication is digital, not analog. So I mentioned earlier, if you're old like me and you used one of the first cell phones, there was a lot of static on those calls. You will not notice a lot of static on a cell call anymore because it's digital, meaning that you're getting the call in ones and zeros and it's being translated back into audio on your phone, and that takes all of that static out of the call. It means that the call is either there or it's not there, rather than fading out with static. That's a good thing because it means that there's not as much problem with interference or attenuation. That's the static that kind of when it fades out because of the distance from the cell tower. But calls can become digitized and difficult to understand, just like a VoIP call where the internet bandwidth is low. The same thing can happen with a wireless call. If the bandwidth is low, you're going to start getting a digitized sound to the voice. It kind of sounds robotic or like it's going through an auto tuner, or it can just drop out entirely. So as opposed to, it kind of fades out, you can still hear them even though it's staticky, like in the old days. Now, if the signal gets poor enough, the call just drops. So that is something that you need to keep aware of with wireless calls to 911. And as I said, wireless calls make up around 90% of all the 911 calls in Colorado. So they are by far the most common type of 911 call that you will take. And I think it's important too, this isn't really talked about in the book, but I think it's important for us to understand that there is a merging right now of wireless and VoIP that's taking place. The distinction between what is a wireless call and what is a VoIP call is disappearing. As I said, almost all wireless calls are digital now. So the fact that they're delivering it with ones and zeros means that there's not really a distinction between a VoIP call and a wireless call, except that the ones and zeros are being delivered by radio signal rather than over a cable or fiber or copper line like a VoIP call would be. Most new handsets are capable of making voice calls over Wi-Fi connections too, using VoIP protocols. This is called Voice over Wi-Fi, or VoWi-Fi. That might be my favorite acronym of the evening. And what this means is that if somebody calls you from within their own, let's say if I called 911 right now, for instance, my cell phone is on my home Wi-Fi, and the phone will actually check which is stronger, the cell signal that I'm getting from the closest cell tower, or the user's Wi-Fi, which the phone is also connected to. Whichever one is stronger, it's going to use that connection to make the 911 call. And so that's important, especially in rural areas where somebody might not have a good cell signal at their house, but they have a Wi-Fi router that's connected to their cable internet or whatever type of internet they may have. And so they can make phone calls, including 911 calls, over that Wi-Fi network. And increasingly, handsets can also make VoIP calls over cellular internet connections. And this is called voice over LTE or VoLTE. And this is, I think, going to become more and more common in the future, where people may buy a device, a smartphone like this, but they may not want to use the voice service that comes with that, or they may buy a data-only service that only gives them internet and no voice capability, and then use an over-the-top VoIP app on the phone to make phone calls, including 911 calls. And I think that's going to become more common in the future as younger people with more technical savvy are buying handsets and try to find ways to cut down on their subscription costs. That would be one way to do it. So the introduction and then explosion of CMRS use in the US was a challenge to 911 systems, which underwent a number of modifications to accommodate 911 calls. So there was sort of an evolution of how 911 calls came from wireless devices. Originally, and I remember the old wireless car phones. Those could not call 911. You had to find another type of phone to call 911 if you had a 911 emergency. But when they did start working to call 911, originally they came in with basically the equivalent of basic 911, meaning that even if the PSAP was equipped for enhanced 911, the call would come in on a 7-digit or 10-digit number. It would not come in on a 911 line, which also meant that there was no alley or other location information associated with the call. This today is called phase 0. Back then, they didn't have a name for it. It was just, that's how wireless calls were received at 911 centers. There are no phase 0 911 centers in Colorado anymore, but there are still many places in other states in the US with wireless phase 0, where if you make a 911 call from a cellular device in that county or in that state, the call will go to a 7 or 10-digit number, and there's no location information associated with it at the PSAP. Usually we're talking about very rural areas, places with a lot more land than people, like Alaska or parts of Nevada, but they do exist. FCC rules required, now we're going into phase 1. So FCC decided that this was a problem, and they wanted wireless 911 calls to be handled or received at 911 centers similar to how calls come in from landlines. So the FCC put together rules that required wireless providers to begin delivering what they called phase 1 911 calls within 6 months upon request of a PSAP, beginning April 1, 1998. That's how far back this goes. And it's really hard for me to fathom that, because it was happening just as I was starting my career in 911. Wireless phase 1 service includes delivery of the call via the 911 network on a 911 line rather than a 7 or 10-digit number at the PSAP. So it would deliver the call to the PSAP on a 911 line rather than on an admin line. And it also included what still is called today a pseudo-ANI or P-ANI. And I would be very surprised if that term is not on your test somewhere. So make sure you know what that means. A pseudo-ANI or P-ANI consists of 2 parts. There is an emergency services routing key, or ESRK, which is a unique identifier used to route the call to the appropriate PSAP. And there is an emergency service routing digits number, or ESRD, which is a number that identifies the cell sector As I mentioned, the cell sector is part of the cell tower from which the call originated. So you're going to get an alley, or you get a P-ANI, you get a number, a phone, and it looks like a phone number. But it is not a phone number. It is a code that associates the call with a routing scheme to the right PSAP, and also tells you which cell tower which cell sector it comes from. The P-ANI is delivered to the PSAP in the alley display. Depending on how your alley display is configured, you may see this P-ANI in your alley along with the actual callback number for the caller. And so this is why you actually get two different things that look like phone numbers in an alley display for a phase 1 wireless call. One of those numbers is a P-ANI. It's not a phone number that you can dial. It is it is basically a number that goes with the alley record for that cell tower sector. And then down in the body of the alley spill, you'll get the actual callback number for the caller, assuming that it's a phone with service. A record is created in the alley database for each P-ANI, but the record is updated dynamically when the call is made to provide the caller's callback number along with the P-ANI and the address of the cell tower. So I mentioned earlier how VoIP calls dynamically build a alley record when the call is made. The same thing is happening with wireless calls. When somebody calls 911, it builds an alley record in the alley database for that call, so that when the PSAP bids the alley database, it's getting a record that has the caller's callback number in it. Then phase 2 worked fairly similar. So once a PSAP had phase 1, and they could actually request both at the same time, but once the PSAP had phase 1 and they wanted to move to phase 2, they would make a request to the wireless carriers, and the wireless carriers had 6 months to start delivering calls to the PSAP in phase 2. So the method for routing wireless phase 1 calls, and this is in the book. I don't know whether it's or not it's going to be on the test because it's pretty obscure information, but it was in the book, so it is possible. The wireless phase 1 call delivery method is called non-call associated signaling, or NCAS, whereas the method for routing phase 2 calls is called wireline compatibility mode, or WCM. There are other differences in the technical call flow between phase 1 and phase 2 that are covered in the study guide, but I'm not going to get into them here because we would need a whole day to talk about them, because there was a lot in the study guide, but I would really encourage you to take a look at it. The biggest difference from the PSAP perspective is that phase 2 wireless 911 calls include location information. So wireless 911 calls determine the caller's location, and how it does that will actually be covered in another section where we're talking about GPS and location services. But when it does determine the caller's location, the estimated location of the caller in XY coordinates, which correspond with latitude and longitude, are included in the alley data that comes in with the call. And this allows, if you've got the equipment at your PSAP, which most PSAPs do, this allows your equipment to actually plot the location of the caller on a map that the call taker and the dispatcher can see. Increasingly, phase 2 wireless calls are also including a Z-axis number, which corresponds to the estimated elevation of the caller's location. And we could talk about that quite a bit too, but it's not in your book, so I'm not going to take our time with it. But if you're ever interested in what that number is about, the Z-axis number, that is referring to the elevation of the caller's location. And the hope is that someday we'll be able to translate that to things like what floor of a building a person is on, although right now it's not easy to do that. Some other terms that you need to know, and again, I apologize for all the acronyms, but these are all in the book, and so they are important for you to be aware of. A mobile switching center, or MSC, is the CMRS equivalent of a central office. I talked about central offices in a previous session, as did Michael in one of his previous sessions. Central office is the switching station. It's a physical building in which landlines are, where landline connections are made to other parts of the public switch telephone network. In the wireless world, it's called a mobile switching center, or MSC. This is the first place a call goes to after being received by the cell tower. A service control point, or SCP, is a routing service used in SS7, which is a type of network structure, and other network structures that is used to route phase 1 wireless calls. So SCPs were retired as we moved from phase 1 to phase 2, but a lot of the country still has phase 1, so they're still in use in other parts of the country. Callback number, we know what that is. That's the number that you can actually use to dial. You can actually dial that to call someone back if they call 911 from a wireless device and get disconnected. But there is an acronym for that, and it's CBN. So if you see CBN, that's what we're talking about, is the callback number. And it's simply important to remember that that is different than the PANI. So on wireless calls, you can see two different numbers that look like phone numbers. One is a PANI and one is a callback number. A mobile positioning center, or MPC. Another term that is similar is Gateway Mobile Location Center, or GMLC. I usually see MPC by itself. The book has them together with a slash like this, but usually I just see MPC. But this is used instead of an SCP, which is up here, the service control point, to route phase 2 wireless calls. What it does is it determines the routing based on the cell sector of the caller. As location-based routing is rolled out, it will start routing calls based on the estimated location of the caller rather than the cell sector. So I know this is really dense information. That was part 2, which is CMRS, or wireless/cellular 911. What questions do we have? We're all in a daze. I can't see any of you because your cameras are off, but I can almost see the little birds going around your head. It is a lot. So my only suggestion is to go back through the book. If you don't have a copy of the book, I recommend getting one and going through it before you take the test, and refresh yourself with these terms, because I guarantee some of this will be on the test. I can't tell you which parts of it will be on the test, but some of it will be. Part 3 is multi-line telephone system interconnection. Multi-line telephone system is frequently abbreviated as MLTS. Another term that you will see is Enterprise Communication System, or ECS. That is a newer version of the term, but they mean the same thing. They're both talking about systems that are meant to serve a particular facility, or sometimes multiple facilities, where it is desirable to purchase a large number of lines at once. Examples of these are big office buildings, schools, college campuses, military installations, and hospitals. Those are just a few examples. There's probably a lot more that I'm not thinking of. But anytime you have a office building, for instance, where there are lots of different offices with different extensions, those are multi-line telephone systems or enterprise communication systems. And they do create a great deal of complexity and challenges when interconnecting with 911 systems. There have been some recent changes due to FCC regulations on how these interconnect with 911, but they are still very challenging to the 911 system. So some of the challenges that they present are often the same address. This used to be the case. This is not as much anymore, but you might still see this in some places, where often the same address would display in the alley for any 911 call that originated in the MLTS, even if the MLTS served multiple addresses. The best example I have of this is from my hometown, Springfield, Missouri, where I started taking 911 calls. We had a hospital system that had two hospitals. They had two hospital facilities, one in the north side of town and one in the south side of town. And they had one MLTS system that showed one address. So if anybody called from anywhere in either of those two buildings, even though they were 15 miles apart from each other, it would show the same address in the alley display. So it was very much part of our early training that if you see this address come up, that may not be where they are, and you had to double check. Even if all of the extensions exist at the same address, the building could be multiple stories. And I said, and Allie provided no information about where in the building the emergency is occurring. That was true in those hospitals as well. They were each 10 stories tall. And if somebody called 911 from anywhere in those two buildings, it would show the same address and not provide any sort of room number or floor number to help know where the call is coming from. And calling the number back would often get the main switchboard for the MLTS or a reception desk and not the person who called. So if somebody called 911 and hung up and we called the number back that showed on the Allie display, we would get this main switchboard and we'd say, hey, do you know if anybody called 911? And sometimes they could check and find out, and sometimes they couldn't. So there was these traditional MLTS implementations that we dealt with for many years had a lot of really big challenges for 911 and for first responders trying to find out where 911 calls came from. Callers had to dial a digit like 9 first to get an outside line. Sometimes they use 8 or another digit, but 9 was frequently the number you had to dial to get an outside line. And so if you needed to dial 911, you actually had to dial 9911. The first 9 gets an outside line, and then you dial 911 to get 911. That's really confusing in an emergency, especially when we teach kids in school, hey, if you ever have an emergency, dial 911. We never told them, unless you're in an office building, and then you might have to dial 9 first, then 911. So that obviously was a huge problem. Some MLTS didn't deliver 911 calls to a PSAP at all, but sent them to a security office or a receptionist desk. In some cases, that might be okay, but in a lot of cases, that's not okay. If they have any sort of emergency that requires first responders, having that call intercepted by a reception desk obviously is going to delay that response. And then once first responders arrived on scene, they often had no information about where in the building the emergency is occurring, and they had no idea who to even ask. So they would have to search the building floor to floor to try to find out where the emergency was. So this started to change in 2017. There was a bill called Carey's Law. It's the Carey's Law Act that was passed in 2017. It was named after a woman named Carey Hunt, a woman in Texas who died when she was attacked in her hotel room, and her daughter attempted to call 911 but was unsuccessful because she didn't know that she had to dial 9 first. So this poor little girl was dialing 911 over and over, and it wasn't going anywhere because she didn't know that she had to dial 9 first to get an outside line. And as a result, the call did not go to 911. So what this bill did is it requires all MLTS to allow direct dialing of 911 without having to dial another digit for an outside line first. It requires all 911 calls to be delivered to a PSAP rather than intercepted at an internal location or security office. And it requires on-site notification so that personnel at the location can help direct first responders to the location of the emergency. So it's not intercepting the call at that on-site location, but it's notifying them as well as delivering the call to 911. And an example of that you can think of like a hotel. If somebody dials 911 from a phone in a hotel room, that call will now go to the PSAP, but it also notifies the person at the front desk of the hotel, hey, room 318 just dialed 911. That way, when first responders arrive on scene, the front desk can help show the first responders how to get to that room. In a hotel, that might not be as big of a deal, but in an office building where you've got these maze of offices and it would be really hard for the first responders to find that room, that can be a real time saver and lifesaver. And then something that came right after that was something called Ray Baum's Act. Ray Baum was a guy at the FCC, I think, that they named this after. But this came out the year after Carey's Law. And what it does is it requires MLTS to provide dispatchable locations to the PSAP. This means that it can't just give a generic address for the whole facility anymore. The alley data must include something more specific, like a room number or a floor number or some other similar information necessary to locate the source of the 911 call. One important thing with this is that this law grandfathered in older systems. So did Kerry's law, meaning that if it's an old MLTS system, it doesn't have to meet these requirements, but any new system purchased, installed, or upgraded after February of 2020 must meet the new requirements. And that's for both Kerry's law and Ray-Baum's Act. The study guide goes through a lot of detail on MLTS configurations, so I'm going to talk a little bit about that. There is MLTS using a main phone number. That's one configuration, meaning that all calls from the MLTS facilities present at the PSAP with one ANI, so they provide the same generic alley. If it's the same ANI, you're going to get the same alley every time. So no matter where in the facility the call originated. So that was one problem that we talked about earlier. Some MLTS providers, even before Kerry's Law and Ray-Baum's Act, tried to address this by using a service called PS Alley, which stands for Private Switch Alley. These are, in a Private Switch Alley configuration, extensions in the MLTS have their own ANIs, or ANIs may be assigned to a group of extensions, and a PS Alley service loads the alley records corresponding to those ANIs into the alley database. So when somebody calls from a facility using an MLTS that has PS Alley service, you would get a more specific location than just the general address of the entire facility. Whether it would be specific enough to meet the requirements of Ray-Baum's Act is another question, but it would be better than just getting a generic address for, you know, a 10-story building with hundreds of offices in it. And another configuration that could be used would be MLTS using emergency response locations, or ERLs. This was a method that was proposed through NENA's model legislation for MLTS. And in this type of configuration, the MLTS facility is divided into zones, and each zone is assigned an emergency location identification number, or ELIN. And the MLTS delivers this ELIN instead of an ANI, and then the ELIN can then be used to deliver a specific alley to the PSAP. I will be honest with you, I don't know if anybody ever used this in the real world, but because it was NENA's proposal and because it's in the book, I wanted to make sure that you were aware of it in case it does come up on the test. Another configuration that is sometimes seen are host MLTSs with remote MLTSs. This is a configuration that is used where an MLTS supports facilities that might be in different 911 service provider areas. Each facility has its own connection to the local 911 system service provider and will provide an ANI that will allow the call to be routed to the appropriate PSAP. So let's take that early example I gave of the hospital that had two locations, one on the north side of town and one on the south side. In their case, one PSAP covered both the north and south side of town. But let's say that wasn't the case. Let's say the north side of town had a PSAP and the south side of town had a PSAP. In that case, because it was delivering one ANI for both locations, that means the calls would always be delivered to one of those two PSAPs, which means that probably half the time it's going to the wrong PSAP and it's going to have to be transferred. So one of the things they did early on, before Kerry's Law and Ray-Baum's Act, is they would have remote MLTSs where you have one MLTS system, and then a facility in another PSAP service area would have a remote MLTS that would deliver a different ANI so that the call could at least be delivered to the correct PSAP, even if it's not showing the correct address. Additionally, a host MLTS manages the direct inward dialing, or DID number, for each extension in a database. And if it did that, that would allow them to give specific locations for each phone number in the phone system. All of that would get loaded into the alley database as if they were separate phone numbers and not just extensions in a local multi-line telephone system. This looks funny because I actually took a screenshot of one of the diagrams in the book. I don't like most of the diagrams in the book, but I thought this one was more helpful than most of them. If you have two facilities that are in two different PSAP service areas, the host MLTS can be in one PSAP service area, and the remote MLTS is in a separate PSAP service area. It might even be a different 911 system that serves that PSAP. So in our case, we have CenturyLink for the entire state, but if both of these facilities were in different 911 system service provider areas, it could actually deliver that call to a different 911 system service provider as well as a different PSAP. Over time, we're seeing those traditional landline or those traditional analog style multi-line telephone systems getting replaced with VoIP-based MLTS systems, or IPS or IP rather MLTS systems, or Internet Protocol MLTS systems. This is the vast majority of new MLTS. If a company went out today to buy a phone system for their facility, it's probably going to be a VoIP system. It's not going to be a switch-based system using analog connections. So VoIP providers, usually specialized in providing MLTS, provide phone service to facilities through a hosted IP-based MLTS. These are cheaper and easier to install for facilities, and they are also more capable of providing specific locations with each extension within the 911 system. Because these systems operate over a connection maintained over the public internet, they can be distributed across multiple jurisdictions more easily and even multiple states. And the number of outgoing lines can also fluctuate dynamically depending on the needs of the customer. Providing a specific location for each extension is possible by matching the IP address of each extension to a location database, which is maintained either by the provider or the customer. However, this is susceptible to error if the database is not kept current. The ability to use non-traditional devices like laptops instead of handsets, for instance, also creates a challenge for locating 911 callers. So for instance, as a state employee at Department of Regulatory Agencies, I have WebEx installed on my laptop, and I can actually make phone calls through the WebEx app on my laptop, including calling 911. But if I pick this laptop up, it's hard to say, laptop up, put it in my briefcase and go to another location, and I use it to call 911, that laptop does not know that I moved. So you might get the call routed to the wrong PSAP, and it will definitely give the wrong address. So these are important things to remember if you're getting calls from MLTS these days, because they are all basically VoIP systems that might be using software that exists on computers rather than on traditional handsets. So that was a lot, and I apologize for how complicated that is, but all of that is in the book. This is an area of 911 service that is evolving rapidly, which is part of why it's so complicated. Does anybody have any questions at this point on MLTS? Okay, I'll move on then. Part 4, we're going to talk about both text to 911 and real-time text. Text to 911 generally is the ability to send a text message to reach an emergency 911 call taker from your mobile phone. Text to 911 is also sometimes referred to as SMS to 911. So if you see SMS to 911, that is the same thing as text to 911. SMS stands for Short Message System, which is just another name for texting. One important thing is that this is not, there's no standard for how this is written. I noticed that it's even written 2 different ways in the study guide. So you'll usually see it spelled as text to 911 without, there are dashes in there, but the dashes are between text and 2 and between 2 and 911, but there's no dashes in 911. But the study guide also uses text to 9-1-1 and text to 9-1-1 without the dashes in the words. So it gets really confusing. But if you're ever writing something about text to 911, if you're writing a policy, really the only standard is to be consistent. Whichever way you choose to use it, make sure you use it that way every time, unlike our study guide. Currently, most jurisdictions in the US that are providing text to 911 are using what's called interim text to 911 or an interim text to 911 solution. And we'll talk about what that means. The type of text to 911 solutions that are currently being used throughout most of the country is considered interim because it is meant to be as a temporary solution until next generation 911 is widely available. A fully NENA i3 next generation 911 system is able to receive and deliver text messages to PSAPs via the same network that's used to deliver voice calls. Until then, though, until next generation 911 is fully developed and available nationwide, PSAPs have used a number of different solutions that bypass the 911 network and deliver text messages to PSAPs using either a direct IP connection or a connection provided over the public internet. So text to 911 availability, PSAPs have to opt in to providing text to 911 service. This is much the same way that they had to opt into becoming a wireless phase 1 or phase 2 PSAP. Most PSAPs in Colorado provide text to 911 service, but a handful still do not. And if a PSAP does not accept text to 911 calls, if somebody tries to text 911, they will get what's called a bounce back message, which informs them that text to 911 is not supported in that area and that they should call 911. Per the study guide, most text to 911 services will not support pictures, videos, attachments, or messages sent to more than one recipient. In fact, I think the book says that text to 911 in general does not support that. However, I have heard from PSAPs here in Colorado that have reported that their chosen service does support multimedia. So it may your mileage may vary depending on what type of text to 911 service you have. You may be able to get pictures, videos, and other attachments that are sent to by text to 911. But generally speaking, these types of services do not support those. Text to 911 also does not work when a subscriber is roaming on another network from the one that normally carries their service. So let's say you are a Verizon customer, but there's no Verizon cell tower anywhere near you, so you're roaming on an AT&T tower. You will not be able to text 911 if you try it. You'll get a bounce back message. NENA and other organizations have promoted the call if you can, text if you must campaign, which encourages users to only text when a voice call is not possible or not safe. And the reason for that is because it generally takes a lot longer to process a text to 911 call than a voice call. The average duration of a voice call is somewhere around 2 minutes, whereas the average duration of a text 911 call is around 7 minutes, because it takes longer to communicate back and forth by text than it does to just talk to each other. So that's why NENA and other 911 organizations have promoted that call if you can, text if you must approach to public education. So how interim text to 911 works. First, a user sends a text message to 911. No dashes. They just put in the numbers 911 in the text in the send field, the to field in the text message app. The CMRS provider, remember that's another name for wireless provider, transmits the text to a text control center, or TCC. There are currently 2 TCCs serving all of the wireless carriers in the country, and all PSAPs receive their text to 911 calls from one of those 2 TCCs as well. The TCC determines, I've got an extra word in there, it determines the location of the caller by querying the location service of the wireless network handling the text. The location server provides the commercial location-based service coordinates for the user. This also means that text to 911 was designed from the beginning to route calls based on caller location and not cell tower location, which is nice to know. The TCC plots the user's location against a PSAP GIS data set, which is basically a electronic map to determine which PSAP should receive the text message. If the PSAP receives its text to 911 service through the other TCC, it is transferred. The TCC then determines which of the several methods the PSAP uses to receive text messages, or if the PSAP has not implemented text to 911 service at all. If the PSAP has not implemented text to 911 service, the TCC sends the caller a bounce back message. And if the PSAP has implemented text to 911, the TCC transmits the text to the PSAP using the PSAP's preferred method to receive it. And that gets into our basically 4 methods for how 911 centers can receive text to 911 calls. The first one is direct integration to your customer premise equipment, which is another name for call handling equipment. So that's CPE or CHE. A PSAP may subscribe to a service that uses either a direct IP connection or a connection over the public internet from the TCC to the PSAP. Call handling equipment at the PSAP must be capable of receiving and processing the text to 911 call. So this is if you're getting text 911 calls directly in your phone equipment, the same screen that you're taking voice calls on, that's where the text calls appear. Web service is another way where a PSAP may subscribe to a service that receives text 911 calls via a dedicated connection or the public internet and receives the text message on a web browser in the PSAP. A lot of 911 centers in Colorado chose to go this way, especially early on, because it was the cheaper option than trying to get a phone system that would receive it as an integrated service. So they receive text messages on a separate screen in a web browser interface. TTY TDD interface. If that is used, the TCC can convert the call into a TTY call. So it's the same as the special phone that you use or comes into your phone system as if it were a call from a person who's deaf or hard of hearing using a TTY device. And the PSAP would use its own call handling equipment or a standalone TTY device to receive the call. To my knowledge, this has not ever been used in Colorado, and the reason for that is because it is susceptible to garbled communication. Sometimes the letters would get garbled, and it also ties up the phone line the entire time that you're on the text call with the caller. So it's by far the least effective method for receiving text 911 calls, and as far as I know, it's never been used in Colorado. And then the 4th interim method that PSAPs can use to receive text 911 calls is over an EZINet or IP I3 network service interface. If the PSAP is served by an EZINet, the text to 911 or the TCC can deliver text to 911 calls to the EZINet, and then the EZINet will transmit the call to the PSAP, which must then receive the call either on their call handling equipment or on a web browser. And this is still considered an interim method, even though it's being delivered via the EZINet, because in a full I3 environment, the wireless carriers will deliver text 911 calls directly to the EZINet, and the TCCs will be retired. But the TCCs, in our case, will not be retired until basically every wireless carrier in the country is able to deliver text messages directly to EZINets. And this method, this 4th method, is actually being considered in Colorado right now. There is a proposal from CenturyLink at the Public Utilities Commission to start doing this in the future, delivering text calls over the EZINet to the 911 centers. Before I move on to real-time text, does anybody have any questions about text to 911?
I have a quick question, Daryl.
Go ahead, Jennifer.
Does text to 911 have the same priority as a 911 phone call?
So that would be more question for your PSAP. If your PSAP has a policy saying text to 911 has the same priority as a 911 call, then it would.
Sorry, I meant with the carriers.
With the carriers. So text, and this is an interesting thing about how text works in wireless networks. Texts are actually delivered over different channels than voice, meaning that there really isn't a priority issue because they're delivered over completely separate channels. Does that make sense?
Yeah.
So if a network, and this will happen too, if a network is completely saturated, for instance, they can't handle any more voice calls on a cell tower, sometimes you can still get a text through because it uses a separate channel to deliver text messages than it does voice calls.
Okay, thank you. And then when you say it text to 911 can't be delivered if the carrier, if they're roaming? Is that the same as if the wireless phone is in SOS mode?
No, not necessarily. If it's in SOS mode, that means that they have activated 911 on their phone, but they can still be on the same network. You know, if you're a Verizon customer, you can still be on a Verizon network and be in SOS mode. The other type of SOS mode, I think the one you're talking about, is if you are roaming on another network that has no service agreement with your main carrier. So let's say you're a Verizon customer and you're out in the middle of nowhere, and there's like a third-party wireless provider cell tower that you're reaching, but that cell tower provider has no agreement with Verizon, then your phone will go into SOS mode, which means the only thing you can do with it is make 911 calls. And in that case, because you are roaming, you will not be able to text 911. You'll get a bounce back message.
Perfect. That's what I was wondering. Thank you.
You're welcome. Anyone else? So real-time text. One of the obvious use cases of text 911, whenever we promote the use of text 911 or encourage PSAPs to implement text 911, is that it's very important for use by people who are deaf, hard of hearing, or have speech disabilities. They can't call 911 by voice. So text 911 is one obvious way for them to reach 911 using the smartphone that everybody has, even people who can't make voice calls, because they are the supercomputers that live in our pockets these days. However, text to 911 has some drawbacks compared to what the deaf and hard of hearing have used in the past for communication, which is TTY devices. The user has to type out an entire message and hit send before anything is received on the other end. With a TTY device, every time you type a letter on the keyboard, that letter is transmitted at that moment to the other user that's on that TTY call. So you don't have to wait until the entire message is typed out and you hit send before you start seeing what they're typing. So a TTY call in that way is faster than a text call. And you could start potentially anticipating what the caller is saying by reading what they're typing as they type it. TTY also allows the call taker to hear background noises. So if you ever get a TTY call, which are extremely rare these days because they're not used very often, but if you ever get a TTY call, if there's background noise in that room, you can hear the background noise because you are actually connecting to that phone through a voice channel, and it's using those special tones on the TTY device to transmit the letters. In emergency call taking, obviously, being able to hear background noise is very important. Texting doesn't do that. If you just type out a text message and hit send, you're obviously not getting any background noise from that caller. So those are two drawbacks to texting compared to TTY. Unfortunately, wireless devices are not good at supporting TTY because of the fact that they are all digital, and TTY does not work very well over digital transmissions. So in 2016, the FCC issued a decision allowing wireless carriers to support a new format called real-time text, or RTT, instead of TTY. RTT works very similar to TTY, but it's transmitted digitally. So you hear background noises, it transmits each letter as you type it. So it works very similar to TTY, but it works over digital networks, whereas TTY does not work over digital networks very well. So some text to 911 solutions being purchased by PSAPs already support RTT, but some do not. And when a PSAP is ready to begin receiving calls in RTT format, it must request it by certifying to the FCC that it's capable of receiving RTT calls before they will be delivered. Now, I will say that to my knowledge, there are not a whole lot of RTT 911 calls out there, but the FCC does require the wireless carriers to support it. And if PSAPs want to be able to receive calls in RTT format, a lot of the text solutions, the text to 911 solutions you're already buying will support those. So you should talk to your text to 911 solution provider, whoever it is, whether it's your call handling equipment vendor, or if it's something that you're purchasing separate from your call handling equipment. You should talk to them to find out if that service will support RTT as well. So that is, let me start with the small thing first. Does anybody have any question about RTT, or real-time text? Okay, so the topics we covered today, we talked about VoIP services, we talked about CMRS or wireless cellular 911, we talked about multi-line telephone systems, and then we talked about text to 911 and real-time text. So it doesn't have to be about the stuff we just talked about, text to 911 or real-time text. If anybody has any questions about any of the other topics we covered today or anything related to these topics. Okay, well, I feel like when I broke out these session topics into specific classes, I accidentally signed myself up for the most complicated ones. So I feel bad throwing all of this at you in a less than 90-minute session. But if you're going over this later, if you're watching the video, if you're looking at the presentation, or if you're going through these sections in your study guide and you have any other questions, feel free to reach out to me. My email address is on this slide here, daryl.branson@state.co.us. Or if you want someone who can explain it better than me, you can talk to Jennifer, Connie, or Monica, whose email addresses are also on here. And I really encourage you to review this in the book before you take the test. And if there is anything that we can help you with, please make sure to let us know. Jennifer, did I forget anything? Or Connie?
No, I think you covered it really, really well.
I do too, and I have a piece of trivia that is not on the test.
Okay.
The first 911 voice over IP 911 equipment in the world was beta tested and installed in Cortez, Colorado.
Really?
Yep.
Interesting. What made them choose Cortez? Do you know?
I was an idiot.
You volunteered.
Well, yeah, we had an IP, voice over IP phone system for the city of Cortez. And we were looking at other equipment, and the engineers from Quebec, Montreal came in, which was very interesting because they lived in my office for about a year. And I joked that I could write code in French. It's still zeros and ones, but it was a very interesting time. And when they did install, we were a tourist attraction for the engineers from CML. They would come through to see our center and then go to Mesa Verde.
That's hilarious. So you should be as famous as Haleyville, Alabama, where the first 911 call was made.
Sure. I will just say that it was literally the bleeding edge of technology,
Yeah.
not the cutting.
Gotcha. Very cool. Well, everybody, I hope you have a good rest of your evening. And again, if you ever need anything, feel free to reach out to me. And I'm going to stop the recording. Maybe.
Thanks, Daryl.